How are we all doing? Afternoon, second last talk. Who's ready for 65 slides? Huh? Nobody? Just as well I've only got 4 slides then, isn't it? All right. So what I want to do today is something a little bit fun. It's coming up to Christmas. So let's use all of our skills. Let's use our skills in embedded systems, or semi-embedded systems, in this case a Raspberry Pi. And let's use our skills in electronics and our skills in programming and do something fun. Right. So what I'm going to do is I'm going to run through and I'm going to teach you how you can create a festive decoration. That is to your entire imagination. I'm basically going to go through basics, LEDs, and a Raspberry Pi, and how you can control it with Google Assistant. So why is this a good project? So it's a good project because it's a good starter project into electronics. And it's a good starter project into programming. Now, some of you may already be experienced in programming and may be experienced in electronics. But what about this? What about if at Christmas you spend some time sitting down with your loved ones, maybe brothers, sisters, children, uncles, aunts, nephews, like anybody, friends, and do something fun together? Because let's face it, you've watched every box set on Netflix. There's not going to be anything on terrestrial TV. You're going to have drunk so much that you're going to be practically sober for the entire Christmas. So do something fun. Teach somebody else how to do something. So who am I? So I'm Nic Jackson. And so I work as a developer advocate at a company called HashiCorp. And normally I'm talking about distributed systems. So that's kind of my day job. My background is that I've worked in software and systems for over 20 years. Predominantly distributed systems, and unfortunately e-commerce has been a big part of my life. And I say unfortunately because most people hate e-commerce, but actually from a distributed systems perspective, it's incredibly interesting. But I've done some things. So I've written a book on microservices with Go, and I'm currently working on my second book, which is going to be all about HashiCorp Vault and managing secrets and application secrets, which is going to be published by Manning as well, which is kind of dope. So slides. Ready for those 65 slides? There's none. All right. So rather than do slides, what I thought I would do is I would build something that's maybe a little bit more useful for you to maybe practice some skills, but also to help you to teach somebody else some skills. So I've built an interactive presentation on instruct, which you can all try and play with. Do we have any Go programmers? 3. All right. Well, that's good. The people who already know Go, it's not all just about Go. And the people who don't, well, you're either going to learn something or I'm going to explain Go concepts in a really terrible way, and you're going to walk out of here absolutely mystified. So I'll share these links at the end, but this is publicly available, and you'll be able to run through this. So basically what we're going to build is we're just going to use something simple. We're going to connect 6 LEDs to the GPIO on the Raspberry Pi. And to control all of that, we're going to use a framework in Go which allows you to get sort of low device driver access called perif.io. And that's kind of cool. But we're going to level this up, right? So we are going to expose a web server on the Raspberry Pi. We're going to make that public on the internet so everybody can hack it. And we're going to link it up to Google Assistant. So just think of this. Just think of the smiles on all of those people's faces when they say, "Okay, Google," like make my Christmas card, turn my Christmas card on, and all of the lights start flashing on that Christmas card. Like, you will be hero at Christmas, I promise you. So let's dig in. So the nice thing about instruct is that in addition to being able to put these slides, I can actually get a terminal as well. So I've built a GPIO simulator for the Raspberry Pi for Golang so that you don't actually even need a hardware device. You can run through the tutorial, you can play with the simulator, and then when you're ready to make the plunge, you go buy your hardware, buy your LEDs, buy your Pi, and amaze your friends. So one of the things that's great about Go, I mean, there's many things, but one of the things that's really great about Go is the fact that you can take the same source code and you can cross-compile for many, many different architectures. So I can build a binary on my Mac, on my Windows machine, on my Linux machine that'll run on the Raspberry Pi. I don't need to install C or make tools or anything complicated on the Raspberry Pi. I'm just going to build the binary, and it's going to be cross-compiled locally. And it's super simple. Any Vim users? Okay. So you're either, those who don't use Vim are either going to love or they're going to hate this. You're either going to learn something with Vim, or, well, you're probably going to burn a whole load of CPUs because there'll be a load of containers open that nobody's managed to quit Vim in. But basically, I've installed Vim on here because instruct doesn't really have an editor, but actually by using Vim, then you can use the Vim Go IDE. So it's going to be a fairly nice experience, and I have put some instructions on there. The most important one, exiting Vim. I do rather like this one. Does anybody remember when Lady Gaga did her? Yeah. All right. So this is the instruct window. So you get a terminal, and let me just, is that big enough at the back? It's big enough, yeah. So you get a terminal window that you can use, and actually we can have multiple tabs in here. So I put some links in here for you. So we've got the tour of Go, in case you want to run through that, and the all-important Vim cheat sheet. You're going to need that to work out how to exit, remember? So let's begin. So the first thing that we want to do is we want to write the basics of a Go application, so the main entry point. So it doesn't have to be in a file called main.go, but main.go is kind of the convention. The thing that it does have to have is a package statement. So for the main entry point, when you're creating a Go executable, you need a package main. So this is kind of like, as I say, the main entry point. And with Go, you can build up your application in multiple files which are in the same package, and you can also build multiple packages which are either subfolders or different Git repositories. It's pretty flexible. So the other thing that we need is a func main. So func, the keyword for function. Oh. I didn't want to do that, did I? So the function, we got a keyword for function, function main, and that's all we need. Okay, cool. So if I want to run that, I've got my basic application, nothing in there. I don't need to compile it. I can just do go run main.go. And obviously it doesn't do anything because I don't have any code in there, but this is a nice thing. You don't have to compile. So Go is a compiled language. That's not a script, but using Go run, it's just a kind of a nice convenience to, rather than having to compile and then running the executable every time. Congratulations. Going good so far. All right. So we're going to add some content to that main function. And a useful thing is logging. So being able to get things out, print statements and things like that. So what we're going to do is we're going to add a logger. So I'm going to define a logger like this. So I'm doing logger, strange symbol that nobody who's used Go before is going to kind of get confused with. Log.new, logger.println. Let's have a walk through that and see what's going on. So what I'm doing, and what this colon and equals, this is a convenience method in Go. So I'm creating a new instance, and I'm assigning it to a variable. I'm doing that all in one go. The alternative to that could be this, right? So I can use the var keyword to define a variable. I can set the type, which is of log.logger, and then I can assign it. So anybody who's used to like C or C++ or anything like that, I'm using a star, so I'm creating a reference. But the simpler method, right? So how you do this, it's entirely up to you. What you'll generally find is that most of the time people are going to write the initializer and the variable assignment all in one go using that colon equals. So the key thing about references in Go, the references do exist. So you've got references and you've got value types. But you maybe don't need to worry about them so much like you would do in other languages. The key sort of thing is that when you're passing objects, that's when you want to sort of acknowledge that there's a reference or a value type. So in our log.new, this is a package function in the log package. And what this is doing is this is going to return us a new logger. But what we're doing is we're passing a reference to the I/O writer, right? So that's an interface. This is the only theory, which is good, because this is where it gets heavy. So in Go, you've got struts and you've got interfaces. Anybody confused yet? Most people. So the thing about Go around, which is different from like many object-oriented languages, is that Go is built by composition. So you don't have concepts like polymorphism and inheritance and things like that. You're defining behavior. So an interface in Go defines the behavior of something. So in what we've just seen, we've had an I/O writer interface, so that means that the strut which implements that interface behavior is a writer. So where this is really useful is that we can pass objects, well, we can pass struts anywhere. You don't have to have concrete types. They don't have to implement everything. You're just going to define the behavior that a particular method or function wants. And as long as the underlying strut implements that method on its interface, then it's acceptable. It's kind of like duck typing. So methods and functions. We saw a function, we saw the func main. So a function is just a detached package encapsulation of code. Whereas a method's just a function that's attached to a strut. So when we define a method, it's kind of we're not using encapsulation like you would do in, say, Java or something like that. What you do is you use this prefix. So we're adding this person, and this, then the function name. And what this is going to do is this is the syntax which will attach say hello to the person strut. So there's an example of how we would use that. So we create a new instance of person, and then we can assign greeting, which is a field on person. And then we can call the method on person say hello, and that will write the output. You can read all that in your own time. Okay, so adding that logger. So most of the things, the way that I've tried to set this up is that you can just cut and paste most of the thing, and you can run through, but I've tried to provide the instructions there so that if you do go through and read it, you can get that understanding, and depending on who you're trying to teach, like, maybe you go easy or go heavy on the theory, but I've added that code there, and the important thing that I need to note is that when I use a package, whether it's in the standard library or whether it's in another library, I've got to use these imports. So I'm using the logging package, so I'm importing the logging package there. So the next thing we want to do is we're going to start going through and we're going to look at how do we interact with that GPIO interface. So we're going to use perif.io. So the first thing we need to do when we use perif.io is we need to initialize the host. So regardless of which application you're writing, this is going to be the same process. So again, because I'm using a package, I need to import it. So this time, because perif.io is not in the standard package, I'm using this URI-based syntax. So I said that, because we don't have potentially a Raspberry Pi connected inside of, well, this demo environment, then what we can do is we can use the simulator. So in perif.io, if I want to switch a pin, then I'm going to, whoops. Oh, Wi-Fi is being bad. I'm going to use this. So RPI, so that's the package, and then we have the pins. So conveniently, for confusion, the pins inside perif.io are not directly addressed. So you'll see things like SO51. This is actually the GPIO pin 15 on the Pi, because I think this is referencing the pin on the chip as opposed to there. But you'll find in the documentation that sort of information, and everything you need for this project is in here. So we've added perif.io. We've set the pin to high, so we're going to pass current to pin 15. If I go into my terminal and run my application, because I'm using the simulator, you can see that I've got a simulated, well, pin 14, I was lying, not pin 15. We've got a simulated pin 15 there switched on. But switching on the pin isn't particularly interesting. What we want to do is make it flash. So to make it flash, what we're going to do is we need to cycle the state. So rather than having this very simple example, what I'm going to do is I'm going to create an object. Well, I'm going to create a strut in Go. So what we're doing here is we've added this method cycle, and cycle is just going to constantly loop. So it's just going to loop all of the time, and it's going to flip the state between high and low. And as a delay, we're just going to delay things half a second, so 500 milliseconds. Now, in most languages, you're going to block, right? So a constant loop is going to block the main thread, and Go's no different. But what you can do in Go is use the Go statement. And the Go statement will allow you to spin up another Go routine which contains your code. So cycle now isn't going to block for us. If I run this code, and if I remember just to change something. What we're going to see is that now when we're running, the LED is going to be flashing because we're cycling the pin to be the high and the low state. So we're switching on and off the current. You can see it kind of flashing there. But that's not so interesting. What we want is lots of LEDs. So the beauty of this is that we've created that strut which defines the pin cycle capabilities. So all we need to do is just add more of them. So we're going to add six pins here, which are defined up there. And we can just duplicate everything we had. And replace so now when we run our code, we've got 6 pins flashing. Well, that's not very interesting. So let's level the ladder. So what we're going to do now is, rather than that being that static half millisecond flash, let's just make it a little bit random. So again, using some of the Go standard library, I can use the random package. So if I take my code, and instead of having that static sleep duration, I'm just going to change it. Oops. What I would do. So now what's going to happen is that we've now got randomly flashing LEDs. Because what I've done is I've defined a sleep duration, which is of a maximum of 1,000 milliseconds and a minimum of 300 milliseconds, and I'm just passing that to time.sleep. So they're going to twinkle a little bit. So we're nearly there. So the next step, what we want to do is, it's no good just running go run when we want to switch this thing on. We want to be able to switch it on and off remotely. Because if we're going to trigger things with Google Assistant needs to be able to do something like call a URL. So we can do that in Go, because again, we can leverage the standard package, and we can build an HTTP web server in 3 lines of code, which is pretty awesome. So let's make some more changes. And what I'm going to do here is I'm going to replace these cycle calls where I was switching on that LED on and off. And I'm going to define an HTTP handler. So a single line of code, I'm defining an HTTP handler in Go on the path /, so the root, and there's going to be a query string. So if you pass a query string with mode on, it'll turn the LEDs on. If you pass it with mode off, it'll turn the LEDs off. So that sets up the handler, but we also need to initialize the web server, which is going to be really complicated because it is like another entire line of code. You know, Python is really popular for sort of hardware hacking. But in my humble opinion, the power of the Go standard library, I mean, you get pretty much everything that you need. So let's run this. Go run main.go. All right, nothing going on there. So what I've done, though, is I've got that web server running. So let me curl localhost 9000 mode on. Sparkly LEDs. Right. Nearly there. So I mentioned about the compilation step. So what we've been doing so far is we've been running Go run. But what we really want to be able to do is to build that binary. So if I just wanted to build a binary in the architecture of the machine, in this case it's going to be Linux, then I can just use this command go build. So I'm specifying an output name, and I want the binary to be called GPIO pi, and I'm specifying the files that I want to compile. So this just has to be within the local package, and it's just going to be main.go. So we've got that there. I can run my binary, distribute it, upload it to GitHub releases, anything I want, but that's there. With the Raspberry Pi, we need to do something far more complicated because we need to build for another architecture. So in the last sort of 15 minutes of talk, I'm going to talk through how we're going to set up CMake. We're going to install a bunch of packages which are not going to configure properly, so you're going to have to tweak them. You copy all that onto your Raspberry Pi. No, you don't. You're going to build it from Linux. And I'm going to build it from Linux with a single command. But because I'm going to run this on my Raspberry Pi, I don't want to use the simulator anymore. So I'm going to use the real PerifIO package, which is going to allow me to do integration with the hardware. So that compilation is as simple as this. So the only addition I'm making to this is I'm setting the architecture. So I'm going to say that I want ARM as my architecture, and I'm setting the architecture type as 6. So that'll run on the Raspberry Pis 2s, 3s, I think it's ARM ML or something. The 0s. If you want to run on something more modern, you can use 7, and also Go will compile for ARM 8 as well. But that is all I need to create a binary that'll run on this thing, which is pretty cool. And it's going to take a little bit longer to build than previously because it's doing cross-compilation, but I am running it on a container which only has 256 meg of RAM and a shared single core. It's going to fly on your local machine. Now if I run that one, well, it's not going to work, right? Because it's the wrong architecture, which is exactly what we were expecting. All right, so That's all we need to build the code. Now let's build the application. So the ports that we're going to use, we're using GPIO 14, 15, 18, 23, 24, and 25. So I've got 6 LEDs, and what I've done is I've soldered a 300 ohm resistor to the negative leg of the LED. So that's just to make sure that it doesn't pull too much power and damage the GPIO board. So you could have set this up on a breadboard or something like that. I decided to solder it because I'm going to try and win myself some brownie points this Christmas by building my wife a Google Assistant controlled Christmas card. Which geek wouldn't love that? All right, so let's connect these things up. So we've got GPIO 5. Oh, good God, my eyesight. 14, 15, I should have just plugged these in advance, shouldn't I? 18, 23, 24, 25, and I've plugged the negative wire into 25, so don't do that. And then we're going to connect the negative to the negative port, if I can get that on there. Right. That's all connected. So let's fire up the Pi. And I've just lost a wire. Okay. So I'm just going to SSH into my Raspberry Pi, which hopefully is connected to the internets. Once it boots. And I've already copied the application binary onto the Pi, but you can do that with SCP. There are instructions there on how to do that. So I'm going to run GPIO Pi ARM. That's running. So I've got that on my server there. So now curl localhost 9000 what have I done? Oh God, right, I backgrounded it. I'll tell you what we're going to do. Let's just show you how you set this up with systemd. So what I need to do is I need to have this running in the background. So I'm going to run this in systemd. So into the folder, etc. system, I'm going to create, what did I call it? GPIO Pi service. And this is my definition for systemd. So I'm specifying that I want to start GPIO Pi ARM. So let's just save that and run it. And I'm going to start that in the background. So now when I run it. So that's all right, but it's not very cool, is it? We want to make this run with Google Assistant. So how do we do that? So we need to expose that service. It's running locally on my MiFi box. It needs to be on the public internet to work with Google Assistant. So what I'm going to do is I'm going to use ngrok. And ngrok is going to allow me to, it's an application I'm going to run on the Pi, and it's going to allow me to create a tunnel from the Pi to the public interwebs. So I'm going to use reserved domains inside of ngrok. And I'm going to do that because every time my Pi restarts, I'm going to be able to have a consistent sort of name. So let me just create a reserved domain there. Thank you, ngrok. I'm doing a live demo, don't you know? It was probably just protesting anyway because I didn't set that up in Europe. Is the downfall of my demo going to be that ngrok doesn't work? Let's try again. Right, okay. So we've got our reserved domain. So then I can start ngrok. So I'm going to start ngrok using the command here. So we can see that that's running there, and what that's going to do is that's going to expose the domain there to my local host. So there are instructions again on how you can set that up inside of systemd, but for now, let's go into a web browser, public internet, flashy LEDs. We're getting somewhere. We've got 5 minutes, so maybe we can finish this thing. No flashy LEDs. Right. So how do we then trigger that with Google Assistant? IFTT. Like all the things. So we're going to create a new applet. I've already linked my Google Assistant on my phone to IFTT. And what I'm going to do is I'm going to say a phrase with a text ingredient. So I want to say turn card on. No, turn card $. So what that's going to do is the last word that I say is going to be replaced with the $. So, okay, Nick, you are awesome. Turned card $. Thank you. I get praise from somebody, if only it's Google Assistant. But then what we're going to do is we're going to use the other side of that, and we're going to use this webhook. So when Google Assistant fires, we're going to call the webhook. So I'm going to specify the URL that we had, but rather than hard coding on, I can specify the text field, and that's just going to be that final word that I passed into the Google Assistant. So I create that, hit my finish, heartbeat's going up because this might start working. And let's see if we can get this to work. Be good to me, Google. Okay, Google, turn card on. Just thinking. You didn't, did you? I'm not that awesome, am I? Let's have a look at those settings. What have we done? Live debugging, just what we want to do.
Isn't there an extra space or?
Let's have a look.
There was an extra space after the
Ah. Let's give this a test and see. OK, Google, turn card on. But I'm not awesome because you haven't done it. We got 4 minutes. This is going to work. Right. Let's see if that's going through. Ah, so it's being received. But evidently, we're losing our query string. Hang on. There we go. OK, Google, turn card on. We still haven't done it. I'd say is going to be a challenge, right? Nothing that's easy is going to be fun. Let's just check that my application's still running. Well, that could be the problem. Why has ngrok died? Blame ngrok. Don't blame me. It's because I lost my connection. Let's try that ngrok command. 2 minutes. Come on. OK, Google, turn card on. Hey! So you just imagine that in a beautifully hand-drawn card. Like, who wouldn't love that? So I've got some crazy ideas. Where can you go with this, right? Well, where do you go with this? Well, you've already learned some Go. You've learned some hardware hacking. What you're going to do next is level this up. So why not connect a camera to the Pi, use GoCV, which is an OpenCV face detection software on the Pi, and rather than using Google, why don't you get it so that when your loved one, friend, relative, whoever's getting this amazing card looks at it, it turns the LEDs on? I mean, how dope would that be? I mean, like, literally, I am never, ever, ever going to have to ask permission to go out on a Saturday night for the next 12 months. So thank you very much for listening.
The links are all there. You can follow this through on the instruct track, and I'm going to get kicked out, but thank you very much. And if you do have any questions, just find me an email. Thank you.
Thank you, Nic. Also for the final thrill. Very exciting.